Let's start with history of Spark. In 2009, it started as a project at UC Berkeley AMP Lab, and in 2010, it was open sourced under a BSD license. In 2013, Spark became an Apache top level project. In 2014, it was used by Databricks to sort large scale datasets and set a new world record. So, what is Apache Spark? Apache Spark is an open source data processing engine to store and process data in real time across various clusters of computers using simple programming constructs. Now, it supports various programming languages like R, Python, Java, and Scala. Developers and data scientists incorporate Spark into their applications to rapidly query, analyze, and transform data at scale. Let's start by comparing Hadoop to Spark. So, Apache Spark processes data 100 times faster than MapReduce as it is done in memory. So, in Hadoop, the processing is not in memory, therefore it is slower than Apache Spark. So, Hadoop performs batch processing of data while Spark performs both batch processing and real-time processing of data. Hadoop has more lines of code. Since it is written in Java, it takes more time to execute. Spark has fewer lines of code as it is implemented in Scala. Now, let's get into Spark features. So, first Spark feature is fast processing. Spark contains RDDs which saves time taken in reading and writing operations, and hence it runs almost 10 to 100 times faster than Hadoop. In-memory computing. In Spark, data is stored in the RAM so it can access the data quickly and accelerate the speed of analytics. Third is that it is flexible. Now, Spark supports multiple programming languages and allows the developer to write applications in Java, Scala, R, or Python. Fourth is fault tolerance. Spark contains RDD that are designed to handle the failure of any worker node in the cluster, thus it ensures that the loss of data reduces to zero. And fifth is better analytics. Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. With all these functionalities, analytics can be performed better. Now let's get into components of Spark. So Spark has multiple components like Spark Core, Spark SQL, Spark Streaming, mlib, and GraphX. Now Spark Core. Spark Core is the base engine for large-scale parallel and distributed data processing. It is responsible for memory management, fault recovery, scheduling, distributing and monitoring jobs on a cluster, and interacting with storage systems. RDDs. Spark Core is embedded with RDDs, an immutable fault-tolerant distributed collection of objects that can be operated on in parallel. Now, there are two kinds of operations that can be done on RDDs. So, first is transformation and second is action. In transformations, operations such as map, filter, join, union, etc. can be performed on an RDD that yields a new RDD containing the result. Actions, these are operations such as reduce, first, count, etc. that return a value after running a computation on an RDD. So this is all about the Spark Core. Now the main thing is RDDs which have like transformation and action features that provides a strong base for processing in Spark Core. Then there is Spark SQL. Spark SQL framework component is used for structured and semi-structured data processing. Spark SQL architecture is, we have file types like CSV, JSON, HDBC connection, etc. Then there is a data source API over it. Then there is a data frame API over data source API. And then we have data frame DSL and Spark SQL and HQL. Spark SQL framework component is used for structured and semi-structured data processing. So this is all about Spark SQL. Then there is Spark Streaming. Spark Streaming is a lightweight API that allows developers to perform batch processing and real-time streaming of data with ease. It provides secure, reliable and fast processing of live data streams. So an input data stream comes, it is processed by Spark streaming, then batches of input data are then sent to Spark engine, then batches of processed data is now produced. So that is Spark streaming. Then there is the Spark mlib. Mlib is a low-level machine learning library that is simple to use, is scalable and compatible with various programming languages. Mlib eases the deployment and development of scalable machine learning algorithms. It contains machine learning libraries that have an implementation of various machine learning algorithms like clustering, classification, collaborative filtering, etc. Then there is GraphX. GraphX is Spark's own graph computation engine and data store. It provides a uniform tool for ETL, for exploratory data analytics, and interactive graph computation. So that is GraphX. Now Apache Spark architecture. Apache Spark uses a master-slave architecture that consists of a driver that runs on a master node and multiple executors which run across the various worker nodes in the clusters. So master node has a driver program. The Spark code behaves as a driver program and creates a Spark context, which is a gateway to all Spark functionalities. So Spark to cluster manager. Spark applications run as independent set of processes on a cluster. The driver program and Spark context takes care of the job execution within the cluster. So worker nodes are slaves that run different tasks.